The plane pi has Cartesian equation x minus y plus 2z is equal to 3. I need to find a unit vector n hat that's normal to pi. So I know my normal vector is 1 because of the coefficient of x, minus 1 because of the coefficient of y, 2 because of the coefficient of z. So that's how I know my normal vector, the vector perpendicular to the plane, looks like that. To turn it into a unit vector, I'm going to work out the magnitude of that. So 1 squared plus minus 1 squared plus 2 squared, all square rooted is root 6. So if I divide my normal vector by the magnitude, it's going to turn it into a unit vector. And so that's what I've done here. The 1 divided by root 6, the minus 1 divided by root 6, and the 2 divided by root 6. We're then given the equation of a line. And we are told that the line intersects the plane at point P. We need to find the coordinates of P and the acute angle between the line and the plane. So what I've done here is I've just rewritten the plane in its vector form. And I've rewritten the equation of the line just by combining each of the coordinates together. So the 0 plus 2 lambda is the x-coordinate there. The 3 plus 4 lambda, that's the y-coordinate. And the minus 1 minus 3 lambda, that's the z-coordinate of a general point on the plane. Then, to work out where they intersect, I'm going to substitute my general point on the line into the point on the plane. So that's what I've done here. Multiplying out that dot product, we've got the 2 lambda times the 1. We've got the 3 plus 4 lambda times the minus 1. And then we've got the minus 1 minus 3 lambda times the 2. Equaling 3. Collecting the lambdas, we get minus 8 lambda. And then I've added 3 and added 2 to both sides. So I found that the line will intersect the plane when lambda is 1. And so I have then plugged that 1 into that minus 1 into the general point on the line and found that when lambda is minus 1, the line is going through the vector minus 2, minus 1, 2. And so the coordinates of P then is 2 minus 1, 2. We then need to find the acute angle between the line and the plane. So I've just drawn a rough sketch here. I've got my plane, pi. It has a normal vector there, which we know is 1 minus 1, 2. And then I've drawn line L going through the plane at point P. At the moment, I've assumed that the direction there is going up, and that's 2, 4, minus 3. I might be wrong, it might be going the other way, but we'll figure that out in a minute in our calculation. So I'm going to use the dot product to work out the angle between these two vectors. So that's what I've done here. I've got the dot product of the two vectors, and I'm going to divide that by the magnitude of the first vector and the magnitude of the second vector. The dot product of those two vectors is minus 8. The magnitudes of those two vectors are given here. And when I do cos inverse of that to work out the angle between those two vectors, I get 2.222 radians. which I note that is bigger than pi over 2. Remember, pi over 2 is 1.57-ish. So therefore, this is not an acute angle, this is an obtuse angle. So what that's telling me is actually I got my direction wrong when I drew the arrow like this. It should actually have been like this, because I've actually worked out the obtuse angle between these two vectors. But that's fine, because if I just subtract this pi over 2 from my angle, then I'm actually going to get the acute angle between the plane and the line, which is what I needed. So that's what I've done down here. The 2.222, take away the pi over 2, is 0.65 radians to 2 decimal places, and that is the acute angle between the line and the